Vanakkam all, Goms here from Cuban Square. While discussing Devo 380 with the Hong Kong IT team, one of the topic what we had a detailed discussion was around the backup and restore option. So RedHat OpenShift has a product named OADP, that is OpenShift API Data Protection, which has Veliro and Copio to back up the resources like your deployment, servers, persistent volume, etc. Along with this, also can back up the container images from the Intel registry and the persistent volume if you have one. This is also being offered as an operator, so it is pretty easy to install OADP and configure the same. So the OADP backs up the OpenShift applications by using this following process. As you can see, the diagram wherein I have given the 1, 2, 3, 4, 5, 6, the legends as well. So this is taken from the Devo 380 RedHat documentation. So the first one, you can see that the user triggers the backup resource. We have a couple of namespaces. One is OpenShift ADP namespace and the other one is application namespace. So in OpenShift ADP namespace, it uses Veliro. So this will export all the Kubernetes resources from the application namespace to backup storage location. That is, for instance, S3 bucket. And then you can see the third one, wherein the Veliro CSI plugin creates a CSI snapshot of the application volume. And then the data mover clones the volume snapshot content and volume snapshot resource to the OpenShift ADP namespace. And then data mover creates a PVC from the volume snapshot. As you can see, we're just cloning these things. That's why you can see the volume snapshot content here, and then the volume snapshot content here as well, and then couple of PVCs. Then the data mover uses the Copio to transfer the volume data to the backup storage location. And after the backup is complete, the data mover deletes all volume snapshots and the PVCs that were created during the backup process. So the same process exists for the restore option as well. So once the user triggers the restore option in the OpenShift ADP namespace, the Veliro will import the Kubernetes resources from the backup storage to the application namespace. And then the data mover creates a temporary PVC and transfer the application data from backup storage to the new volume. Then the Veliro creates a PVC in the application namespace with the same PV. And then finally, after the transfer is complete, data mover releases the PV from the temporary PVC in OpenShift ADP namespace. This is how it works. So now we'll see the command lines on how to execute the commands using the OC CLI tool to take the backup of the resources, take the backup of the container images, and export the PVC as well. So to start with, I have a set of application installed. The first one would be Etherpad. To access the application, I'll just open this. I have the console here. I have the host port here. And here you can see this is the application. Ethernet pad -production.apps ocp4.example.com. So now this application uses pod, servers, deployment, persistent volume, climb as well. Okay, the one you can see Etherpad. So I need to take a backup of all those things. So to take a backup, the way to do that would be OC get PVC Etherpad -o YAML. So the first thing is I'll just get the YAML format, and from this I would need to remove the status, and then from the spec we would need to remove the volume name. From the metadata field we would need to remove annotations, create timestamps, namespace, resource versions, UID, etc. So that when we import it or when we restore to the different namespace, the resources will get created without any errors. So to start with, what I'll do is I'll just use an option called YQ to remove those. So metadata, I'll just show a couple of examples. Annotations. So if I want to remove one more, I'll just go with YQ metadata that namespace. Like this, I just need to add all the options whichever need to be removed from the YAML, and then finally redirect the output to, for an example, production pvc.yaml. Just redirect to any name for that matter. Now if you see the YAML file, it will contain the details excluding the options whatever we have removed. Okay, and after this we just need to go ahead and take the backup of your deployment, servers, route, and all these options, and then from there we'll just go ahead and expose the internal registry. The reason for exposing the internal registry is we have to take the backup of the container images. To do that, we have a command called ocpatch. Okay, ocpatch configs. Just use the ocpatch help options to get the entire commands. I'll just go with the spec. Okay, my bad. Instead of patch, I've given as path. Okay, then I have exposed the internal registry, and we have to check the OpenShift API server because it will just get redeployed when I run the ocpatch command. So let us go and check it. So once it's done, you just log into the registry. So we have logged into the registry, and then what we are going to do is we are just going to identify the FQDN of the Ethernet pad image, and we'll save that a name to a variable called image like this. Okay, done. So let us cross check. So that's the name. Okay, default route OpenShift-image registry dot apps dot ocp4 dot example.com slash production slash etherpad. So that's the name. So now what we are going to do is we are just going to export all the container images from the Ethernet pad images stream by the OC image mirror command. So I'll just use OC image mirror. File to the directory production. Okay, so it's taking the backup. Done. So after this, we are just gonna take the snapshot of the persistent volume to limit the downtime of the application during the backup operation. What we'll do is we'll also just bring down the replica set. Okay, so I'll just check the PVC. So we have the PVC etherpad. We'll also check the storage class. So especially this one. Okay, and we'll also check the volume snapshot class. So now what we'll do is we'll just scale down the application so that there won't be any outage. I mean, I would say while taking the backup, there won't be any interruption. It will be a consistent backup, that's why. Etherpad. I'll make the replicas to 0. Done. Let us cross check whether the pods have gone down. Done. And then now we are just going to create a volume snapshot of this Etherpad persistent volume. So I have a predefined YAML file here. I'll use that. You can see this. So this is the CR name would be volume snapshot. You can find the volume snapshot name, and the source would be persistent volume climb Etherpad. So from there we are just going to create the volume snapshot. So I'll apply this. Done. We have just created the volume snapshot. So let us verify. Done. So after taking that, let us scale back to replicas 1. That is, we'll make the pod to be running. From 0, I'll just make it as 1. Okay, it's getting started. Okay, it's running. Let's wait for 1 by 1. Okay, good. So now we'll export the application data from the volume snapshot. So to do that, we have to use a PVC snapshot. So this is the one. We have a persistent volume climb. Okay, so we'll use this persistent volume climb by using the data from the volume snapshot. So here I'm using the same storage class name, and the data source would be this. That is a volume snapshot what we just created with the resources of 1 GB. So let us create that. Done. So let us cross check. Etherpad snapshot. Okay, done. And then finally we are just going to mount the snapshot volume on the snapshot in a new pod. So for that I just have a pod. So we have this pod.yaml file. In this, if you see the mount options, you can see the volume mount options. The mount path would be /snapshot, and we have the volume as well. And just note down the persistent volume climb. The climb name would be the Ethernet pad -snapshot, the PVC what we just created. So let us apply this. So in this procedure, we're just taking the backup. Okay, the container is getting created. Okay, done.